Alright guys, welcome to 5-5 Notes Completion. And today we get another shortcut. This week's going to be all about the shortcuts. We had SAS last week. We got Sassy. Well, there's 4 more coming at you. And 2 of them here today in this lesson. SSS and then HL. So let's take a look at what these things mean to us. Alright, so SSS is probably exactly what you think. If you know that all the sides, if all 3 sides of one triangle are congruent to all 3 sides of a second, then the triangles have to be congruent. SSS, side, side, side. No angles are even necessary to show congruence if you know all the sides are congruent. So basically, guys, if I gave you 3 sticks, of 3 different lengths of sticks, and I gave everybody 3 sticks, one this long, one this long, one this long, and said make a triangle, all of your triangles would have to look identical, provided we didn't have any overlap, where all the sides matched up, all the vertices matched up, I should say. So if that was the case, you're all stuck. There's only one triangle that you could all make. Now it might be flipped or turned or spun, but I could position them so that I could lay them all on top of each other. So SSS congruence theorem. So now here's how it'll look. This is about as easy as one could ever be for you to get this party started. And so see what they gave us. They gave us 2 pairs of sides already congruent. So all that stuff in there given. And then we learned last week that we can slash reflexive. So LM congruent to LM. Reflexive property. And that's about as quick as you can get. You got everything you need now. Triangle KLM congruent to triangle NLM, and just rewrite it, what you see there. And your new friend, SSS. All the sides of this triangle match up with all the sides of this triangle. So that's it. Game over. Alright, the monitoring progress. Decide whether the congruence statement is true. So pause the video here, take a look and see what you guys think about these 3 triangles in the monitoring progress. Alright, back again. Okay, so number 1. Single slash, double slash, double slash, triple slash, triple slash. The letters match up. D goes with H, yes. F, J, yes. G with K. So there's side, side, side congruence. Number 2. We got a 9 with a 9 in the middle, 7 with a 7, but I got problems right here. So this is a no. All my sides do not match up, so it cannot possibly be congruent triangles. And this one looks good, right? Single, single, double, double, triple, triple. Q with R, P with S, T with T. So here's another example of SSS. All right, the second shortcut today. All right, now check this out, guys. We talked last week about there was no angle side side, right? Or side side angle. They didn't want to swear, so they're going to write it backwards. But that's just ASS backwards. So still, last week we talked about this does not work. Here's angle side side, angle side side, and clearly the triangles are not congruent. This one is not the same as this one. But as we read right here, SSA for ASS backwards is not valid in general. There is a special case for right triangles where angle side side will actually work. In a right triangle, the sides adjacent to the right angle are called the legs, of course. The side opposite is the hypotenuse. So therefore, check this out. Hypotenuse leg means you have hypotenuses matched up with a pair of triangles, right triangles, and then you got a pair of legs matched up. If this is the case, so right angle, typically this would have been angle side side. This is not sassy, but the special case is that if it's a right triangle, angle side side actually works. Let me show you why. So here's our instance we had last week in class. We said, all right, this angle is the same as this angle. This side length was the same as this side length, and this side length was the same as this side length. So there was your angle side side, and that's why it did not work. Now essentially, here's what happened though. This hopefully should make better sense of this to you. Check this out. So when I create a new triangle, basically what I did to go from the triangle on the left to the triangle right is to take this last side, don't change its length, just swing it inside here. Now you've made that second triangle that has a completely different area, completely different size as the first one. All right, even though the angle sides were the same. So took it there, swung it in there. Well, here's how you can kind of think of the HL working. Because what if you were straight up and down? If you made a right angle here, then the slashes that were there, and I changed this one, oops, I changed this one as well. You can see how if it's straight up and down, you would be locked in to the same exact triangle. And that's the only case. That's the only time it works. All other angles down here would be like how we started. Oops, not that. Like that. So the only time angle side works is if you're straight up and down. A right triangle. So now the proofs of these will be the same as the other proofs we've been doing, except now you're just going to say, if it gets you to the point where you have angle side, if it's a right triangle, you can use the abbreviations HL. So in this one, all that is given. All right, now check this out. They tell us that WY, that big length, is the same as XZ, that big length. And then they tell us that we have perpendicular. So we've got right angles there and there. So now watch how cool this is. I'm going to separate and redraw these triangles so you can see them a little easier. So for instance, here's what we got. We've got W, Z, Y. That's this triangle. And then this triangle, we've got Z, Y, X. So sometimes it's a little easier to separate and redraw these things, because then they tell you that WY is the same as XZ, so it's a little easier to see the slash. Then the perpendicular tells you have right angles there and there. And now look, the reflexive property, sometimes it's a little bit trickier to see, but ZY is in both triangles. So you can mark it reflexive because it's the same length in both triangles. So we can come at you with, well, first off, let's take care of our right angles. So angle WZY is congruent to angle XYZ. Definition of perpendicular, straight from the given. Right. And now we can do the reflexive ZY. And now we have enough. And typically this would have been angle side. You'd have told me you can't get sassy with that, Mr. Staines. The sides are not surrounding the angle. But this is a special case. If that angle is a right angle. So it got to be something in a given telling you right angle, perpendicular. Yeah, pretty much that's it. It's got to be, you got to know it's a right angle somehow in order to use HL. So then we can say, oh, okay, now we have enough. The hypotenuses match up and the legs match up. And the only time you can have a hypotenuse is if you have a right angle. So that's your clue. So WYZ congruent to XZY and a new friend, HL. So we've had SSS and now we have HL. All right, take a couple minutes, pause the video. 2 last proofs I want you guys to try. All right, back again. This one again, about as easy as you can get. Practicing. And SSS is typically the easiest one because there aren't any angles involved to confuse you. You got 3 sides, you got 3 sides. Of course, we mark the middle reflexive. SQ congruent to SQ. Reflexive. And then now we can say triangle PQS congruent to triangle RQS, side, side, side. 3 steps, as fast as you'll see. They could give you everything, it'd be only 2 steps, but the book's not going to do that. And then this last one, you've got statements and reasons. All that is given. All right, we got the right angle, so we have to say it. We have angle Q congruent to angle S. Definition of right angles. And then we got to go with the reflexive property. PR congruent to PR. Reflexive. And now that's enough to say triangle PQR congruent to triangle RSP by hypotenuse leg. Alright, so 2 new friends today, SSS and HL, and they're adding to our list. So we had SAS, now we have 2 more. Alright, peace!